Assalamu alaikum friends, my name is Bilal Khan and this is my 10th video of DevOps. So in this video I am going to show you the network layer. So in the previous video I have shown you what is transport layer and a little bit about network layer. So the network layer will take the data from your computer to your friend's computer to transfer the data to your friend's computer, and then the transport layer will take this data from the network layer and give to the application layer. Alright, so this is the functionality of the network and the transport layer that we have discussed in the previous video also. So now let's discuss that the data in the network and the transport layer, the data will be transferred in segments. In the network layer, the data will be transferred in packets, and in the data link layer that we are discussing in the next video, the data will be transferred in frames. Alright. So what works in the network layer? So basically the routers work in the network layer. Every router is having its own network address. Alright, so this network address will identify the router. As in the previous video I have shown you that the IP address will identify the computer. So similarly the router will be identified through network address. Each router has its own routing table. So the routing table will show that where is the destination and how you can reach them. So a routing table contains a lot of information, but all the routing tables have at least three information fields. The first one is the network ID. So basically it will show that where is the destination. Alright, it is showing the destination ID. The metric, this is the path through which the data will pass and reach to its destination. So the metric is the path. And the next hop is like a jump from one path to another path. So the path will be divided into multiple segments. So the hopping will take place so that it will jump from one part of the path to another part of the path. So in this way the jumping will take place and the data will reach to its destination. Alright. So here takes an example. Let's take an example that here is device A and device B. So in between these two devices there are a lot of routers. Router 1, router 2, router 3, router 4 and router 5. Alright. So these are the routers that will transfer the data from device A to device B. Alright. So let's say that the router 1 has a network address 1. Alright. So this is basically identifying this router 1. After that, the device 1 send the data to the router 1. Alright. So the router 1 will check in its routing table that where is the next location or where is the destination in which I will send the data. Alright. So the routing table will provide this information. So after that the router 1 will send the data to the router 2. Alright. And the router 2 will understand that the network address 1 or the router 1 has sent me this data. Alright. So after that the router 2 will check the routing table and then it will make sure that where is the next destination. So the router 2 will identify that the router 3 is the next destination, so it will send this data. Alright. And the router 3 will understand that the data is come from router 2 or the network 2, network address 2. Now the router 3 will also check the routing table and see the next destination. So in this way the next destination would be the device. Alright. By skipping the router 4 and router 5, the destination would be the device. And the device will receive this data from the router 3. Alright. So this is the functionality of the routing table. So here is the definition. So the forwarding table comes inside the routing tables. Alright. So basically there are two kinds of table in a router. The first one is the routing table and the second one is the forwarding table. So the forwarding table is present inside the routing table. Alright. So let's see what these table do. So the routing table contains multiple paths. Alright, it does not contain just one path, it contains multiple paths. So the information of different paths and their movement will be in the routing table. Alright. After that, the forwarding table only contains one path. Alright. So these tables are present inside the routers. So these two tables are present inside the routers. Now let's move to the next slide. So here is the IP address. The IP address has two parts. The first one is the network address, starting from 192.168.2. This is the first part, and the second part is the device address, that is 30. Alright. So after that, who creates these tables? As we have seen that the routing table and the forwarding tables are existing, but the question arises that who creates these tables? So control plane, which is in the network layer, creates these tables. Alright. So control plane refers to all the functions and processes that determine which path to use to send the packet or frame. Alright. So it will make sure that which path to send the data. Alright. So there are two types of routing that are used to create a table. Alright. So the routing has again multiple two types. So there is a static routing and a dynamic routing. So the static routing, the administrator will manually add the addresses. Alright. So in the routing table, in the static routing table, the administrator will manually add the addresses. So in the dynamic routing, the router learns about routing information without an administrator's help and adds the best route to its routing table. Alright. So network layer protocol is an internet protocol. Alright. So what is internet protocol? So the internet protocol is a protocol or set of rules for routing and addressing packets of data so that they can travel across networks and arrive at the correct destination. So it will provide a path through which it is providing a pathway also, and it is identifying the device so that the data can be transferred to the destination. Every device or domain that connects to the internet is assigned an IP address. Alright. So with the help of this IP address, the device can easily be identified. And as packets are directed to the IP address attached to them, so if the data is transferred, so the data packets will be attached to the IP address. Data will be arrived where it is needed. Alright. So there are two types of IP address, IPV4 and IPV6. So the IPV4 and IPV6 are Internet Protocol version 4 and Internet Protocol version 6. So IP version 4 is the new version of Internet Protocol, which is way better than IPV4 in terms of complexity and efficiency. So because the IPV4 is not fulfilling the needs of the connectivity that many computers and mobile phones and laptops, many computers are connected nowadays to the internet. So the IPv4 has some kind of limitation that it will not accept more devices. So to solve this problem, the IPv6 came into picture. Alright. So although the industries organizations didn't pivot to this IPv6, instead they are using this IPv4 nowadays, but the IPv6 is created to solve this problem. Alright. So IPv4 has 32 bits and IPv6 has 128 bits. So it is solving a problem of the computers that are nowadays connected more and more to the internet. So here is the picture of IPv4. Here you can write IPv4 5.6. I have randomly write, but it is not written like this. But I have just shown you that it can be written in like this: 5.6.9.14. So each of these numbers will be having 8-bit size. Alright, 8, 8, 8, 8, they will combine to form 32 bits. Alright. So here is a question that the hopping takes place in the ISPs, not in the routers. Why? The blocks of IP addresses are assigned to the ISPs, and that is called subnetting. So basically, let's say I have there are 100 routers that are present on the street, and every home is using it. Alright, so if the router is saving the IP addresses of all the routers, if one router is saving the IP addresses of all the routers, then anybody can access any router. So it is not a good practice. Alright, so instead the router and the block of IP addresses will be assigned to the ISP that is providing the internet. So that ISP will control all the IP addresses, and after controlling this all the IP addresses, the hopping will also take place in the ISPs, not in the routers. Alright, so all the jumping of IP addresses from one place to another will not take place in the router. Instead, the ISP will handle all of this. Alright, and that is called subnetting. So the IP address consists of two components, the network ID and a host ID. So the network ID or subnet ID, is also called subnet ID, identifies the network, and the host ID is used to identify the number of supported hosts. Alright, how many hosts are supported, so that will be called host ID. A host can communicate directly only with other hosts on the same network segment. So let's say there are two hosts, they are connected together and sharing the information, but they are on the same network, so it will be a two-way communication, but on the same network. So a network segment is a logical division of a network into unique numeric and network IDs called subnets. So on the same network, if two hosts are communicating together, so in the same network, the multiple logical division will be created. Alright, to identify that this host is present in this side of the network and the second host is present on the another side of the network, but this whole network will be one single network. Alright, a logical division will be created in a single network to identify both the hosts. Alright, and this logical division is called subnets. So a host must use a router code to communicate with host on the other subnets. So let's say there are multiple networks in which one host is communicating from another network and second host is communicating from another network. So in this way, the router will be used because the network are different. Alright, so now let's move to another slide. So here is the IP address that I have shown you. This was just an example. The IP address will be in the form of like this. Alright, this is the network address and this is the device address, and it is also called the network ID and the host ID. Alright, so now the IP designers carved the entire galaxy of IP addresses into classes to meet the different processing needs. So the IP addresses are divided into multiple classes so that they can be identified easily. Alright, so class A, it's the first class of IP addresses, and that is starting from 0.0.0.0 to 127.255.255.255. Alright, it is the limitation of the first class A. After that, the 127, the next IP address class A will be starting from 128.0.0.0 to 191. Alright, after that class C will be starting from 192.0.0.0 to 223. Alright, after that the 224 will be class D and it will end at the 239. After that the class E will be starting from 240 to 255. So this is the end of the IP address. After that the IP address will not exceed. So this will be 255.255.255.255. Alright. So now let's move to the subnetting. So it is the method through which one network is divided so that router consider it different networks. In one network, if the IP addresses are trying to be divided, so it will be divided logically, alright, with the help of subnetting. So it is a method through which one network will be divided into different networks with the help of subnetting, and these are logically divided. Alright, so here is a network. Let's take an example of it, and these are the two routers that are connected in a network, and these are the IP addresses. Let's say one network is having 60 IP address, the second one is 20, the third one is 10, and the fourth one is 40. Alright, so let's take the 61, and before taking this 60 IP address, let's take the class A IP address. So in the previous slide, let's move to the previous slide. Here is the class A IP address that is starting from 0.0.0. Alright, so the class A IP address will be 12.0.0.0. Alright, so it is the first class IP address, and here is the network. The 12 is the network, and these three are the hosts. Alright, so after that, the second part of this IP address is that each of the number that is present in the IP address will be having 8 binary numbers. Alright, so 12 will be having 8 binary numbers. Similarly, 0 will be having 8 binary numbers. I have written it, but you just need to remember that each of the number will be having 8 binary numbers. Similarly, with this 0, with this 0, all of these will be having 8 binary numbers. So after that, let's do some mathematical calculation. So the mathematical calculation will be starting from 60. Alright, so this is the 60, and the calculation that we will do is 2 raised to the power of number minus 2. And if that number is smaller than, or if that number is greater than or equal to 60, then we will stop this loop. Alright, so 2 raised to the power of 1 is minus 2 is equal to 0. 2 raised to the power of 2 minus 2 is equal to 2. 2 raised to the power of 3 minus 2 is equal to 8 minus 2 is equal to 6. Now it is not reached to the equal. It is not reached to that equal or greater than 60. So now we will move on. 2 raised to the power of 4 minus 2 is equal to 16 minus 2 is equal to 14. 2 raised to the power of 6 minus 2 is equal to 32 minus 2 is equal to 30. Now let's take the another number. 2 raised to the power of 6 minus 2 is equal to 64 minus 2 is equal to 62. So now this 2 raised to the power of 6 has given us the result. In this way, the 62 is greater than or equal to 60. Alright, so it is greater than 60. So now after that, let's take the fourth step, and now the n is equal to 6. Alright, the result that we got is with the help of 2 raised to the power of 6. So the n number will be equal to 6. So what the 6 will do? So here the IP address that I have shown you in the previous slide, let's take this IP address, and from the right side, let's count the numbers until it reaches 6. 1, 2, 3, 4, 5, 6. So these 6 numbers will be equal to host. The 6 numbers that we have gotten, we will take the number, we will count the numbers from the right side, and if it is reached at the end, these numbers will be equal to host, and after that all the remaining numbers will be equal to network. Alright, so now the network bit will be equal to 1 and the host bit will be equal to 0. Alright, so let's take the sixth point. The 12.000 are now have become 111 because it is the network bit. Alright, after that these 6 bits will remain the same because these are the host bit. After that, let's take the decimal values of this. Let's say these are the 8 numbers. Similarly, these are the 8 numbers, these are the 8 numbers, and 12 has also the 8 binary numbers. So every number has 8 binary numbers. So every binary numbers will be having the decimal numbers. Alright, so 0 is having 1, the next 0 is having 2 decimal numbers, the third one is having 4, similarly this 0 has 8, 16, it will be doubled. Alright, this 0 has 32, this one has 64 decimal number, and this one has 128 decimal number. Alright, so now let's take these numbers and apply it into these 1 1. Alright, so after that let's take this 12 and let's count the 1 1. Let's count these the decimal numbers of these 1. So the decimal number of these 1 would be equal to 255. If I add these numbers, the decimal value of these 1 will be equal to 255. And if I add the decimal numbers of these 1 also, it will also be equal to 255. But if I calculate the numbers, add these numbers of these 2 1 only, it will be equal to 128 plus 64, and the result would be 192. So this is the number that I have taken from the decimal numbers, not the actual numbers. Alright. So after that, let's move to the 8 points, and the 8 points is the subnet mask. So subnet mask is of class 1 because we are dealing with class A. So the subnet mask of class A would be 255.0.0.0. These are the classes. The class A has a subnet mask 255. After that, the class B has 255.255.0.0. After that, the class C has this number. So we are dealing with class A. So the class A has a subnet mask 255.0.0.0. Now the subnet and the actual subnet mask would be 255.255.255.192. Where this come from? So basically it came from this one, 255.255.192. We didn't made changes here. We took these changes that we have made here and applied those changes here, and the 255 that was already present, we didn't care about this. We took the changes from the previous slide and add those changes here. Alright, so now the subnet mask of the class A would be this. Alright, so a subnet mask is a 32 bits address used to distinguish between a network address and a host address in IP address. So it will differentiate the IP address and the host address. It helps the router to identify the network. Alright, so here is the subnet ID. So the subnet ID is 12.0.0.0/26. So where is the 26 came from? So let's move to the previous slide. So in this slide earlier, I have shown you that how you can add the decimal numbers. But now let's add the actual numbers. Alright, so these are the 8 bits number. Similarly, this 12 has also the 8 binary numbers. Alright, so let's take this 8 binary numbers, take this one, take this one. So 8, 8, 8. It will become, if it is added, it will become 24. And now let's these 1 1 also, 24 plus 2 will be 26. Alright, so this is the result that we have added the 26. So this is called CIDR, and it shows that how much network bits are present in an IP address. Alright, so these are the network bits. Alright, these are all the network bits that we have shown you. It will start from the 12 to this until it reaches here. Alright, so if it is counted, then it will be equal to 26. So it is basically showing that how many network bits are present in an IP address. So now let's move to the 10th point and calculate the second subnet. So the subnet ID would be 12.0.0.64. So where is the 64 came from? Before showing you the 64, let's calculate this broadcast ID. So the broadcast ID is 12.0.0.63. So now the question arises that where this 63 came from. Let's move to the previous slide. And here you can see that I am in 60. Here is the 64. So why did you take this 64? Why didn't you take 32, 16 or 128? Because if we go from the right side and if we reach at the end of this host, and after that the end of this host is giving us the decimal value 32. But now after the first number, that is the network ID of the this IP address, the first number has a decimal value 64. Alright. So let's take an example that if let's say this number is not equal to 1, this is equal to 0, then our first number would be equal to 128. So because the 1 is starting from 64, so we will take this 64 decimal number. Alright. So let's take this 64 number, and 64, if we subtract 1 from it, that will be 63, and this will become the broadcast ID. Alright. So the number we have taken, subtract 1 from it, and that will become the broadcast ID. After that, we have taken the subnet ID because we have added the 64 to the previous subnet ID. 0, it was the previous subnet ID. We have now added the 64 that I have shown you. Let's add this to 0. Now it is becoming 64. And after that, it is added to again to the broadcast ID. 64, 64, it is becoming 128. 128 minus 1 is equal to 127. Now let's move to the third subnet. The third subnet is 128. Let's add 64. Now let's move to the fourth subnet ID, and the fourth subnet ID would be 192 because 64 is added to 128. Now it is becoming 192. The fifth subnet ID is 12.0.1.0. Why? Because after we add the 64 to this 192, alright, it will become 255. So the 255 is the end of the IP address. So after this, the 255 will become 0, and the 1, it will become 1, and this 1 will be transferred to the next. Alright, so it will go from this 0 to here, and the 255 will become 0. Alright. So this is how you can make the subnet IDs and the broadcast IDs and the subnet mask also. Alright. I hope you understand what I have talked about. So what we have learned today is the network layer and its working, routing and forwarding table, internet protocol IPV4 and IPV6, network host ID, and subnetting. Alright, so that's it. I hope you like this video. If you have liked it, then make sure to subscribe to my channel, and if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.